There's 5 terms. 1, 2, 3, 4, 5. So the number, the term number that it is, would be considered its domain. The range is what the value is. So the first term is 3, second term is 6, third term is 9, fourth term, so on. So what's happening here is we're going to start using what are called subscripts. N, sub n. Right? Well, could you guys figure out what the pattern is going on in that 3, 6, 9, 12, 15? How do you write that as in terms of an equation? 1 plus n times 3. 3 plus 3x.
Number.
See, here's where things are going to start. When you're trying to figure out how to write this in terms of an equation, how do you get those terms? If you're saying 3 plus 3x, where n, you're starting at the first term, if I started at n equals 1, that means it'd be 3 plus 3 times 1. 3 plus 3 times 2. 3 plus 3 times 3.
3x.
See what I'm saying here?
3x.
It would just be 3x. Okay? What's happening here is that this can be written in terms of n as 3n, where the first term, where this n value, determines the number in the sequence. Okay? And they call that the nth term. Yeah. Like the fourth root, fifth root. So if I want to say what's the fourth term, I would say, well, what's a sub 4 in this case? Well, to get the fourth term in this sequence, we took 3 times 4, and it gave us 12. That's what we call it. That's how we write that out.
Did you say range was?
It's the actual sequence. Think of it as 3, 6, 9, 12, 15. Those are the numbers in the sequence. So what happens a lot of times here is that most of these values, you're going to just write out, oh, what's the first 6 terms? Well, it kind of looks like function notation when we're done. F of x equals 3x. If you had to write out first 6 terms of that, you would just use your calculator and your y equals in your table function. First term is x is equal 1, second term is x equals 2, third term is x equals 3, and so on. None of these calculation style problems you would ever get wrong, because you just use your calculator. The difference on the other side, it's an infinite sequence. It just keeps going and going and going and going. And eventually we will spend time talking about infinite sequences, infinite series, and how you can work with them, how you can find sums in them. What most people have problems with is what we call writing rules. How do you write the rule for the sequence? How do you write the rule for it? What is it? How do we write the rule for what they call the nth term? And that is, I want to write this sequence out in terms of a sub n to give me, well, my first term gives me negative 1/3. My second term gives me 1/9. How am I getting that through those? So I want to sit there and I have to look at the values of negative 1/3. The next one's 1/9. The next one is negative 1/27. The next one is 1/81. I need to figure out what is the pattern going on here. What's the pattern going on? It's multiplying by negative 1/3. Very good. The reason that it's multiplying by a negative is because you see how the signs are alternating? Negative times a negative gives you a positive. Negative times positive gives you a negative, and so on. Now, what you're saying here is, how do I write that in terms of n? You're right. You're multiplying each term by negative 1/3. So how would you write that out? Negative 1/3 n. Okay. So if I write it out as negative 1/3 times n, that means that the first term would be negative 1/3 times 1. The second term would be negative 1/3 times 2. And that's not right. Okay? And this is where you can pick up on the pattern relatively easily, but how do you write in terms of the equation? That's where students have issues. That's where a lot of times you start messing around with your calculator. When you say it's 1/3 times n, okay, let me check it, see how that works. Am I getting those values? Well, you're not. So let's try it again. What else could you write that as? How are you going to get it to change signs? 1 over n?
No, I wouldn't mind 1 over n.
If it was 1 over n, then yeah, you get the same idea. Okay. How do you mess around with that to change it up? N equals what?
What is A?
It's just the, it's kind of like saying y equals.
It's like a
Why can't you
placeholder.
just say
Yeah.
X for n instead of n?
They use it with ends with sequences in series.
So
It's if they're interchangeable.
So A is just a placeholder, pretty much.
So yeah, it's kind of like the generic equation. What's another way you can mess around with signs? SIGNs. What's another way you can change it? Okay, divide by, but remember how we just did that with multiplying and it wasn't getting us anywhere? Do you think dividing will get us anywhere?
Oh, and
So,
negative 1 over 3 to the nth power.
Okay, all right. Negative 1 over 3 to the nth power.
Oh, that.
If n is 1, what's negative 1/3 to the first power?
Negative 1/3.
What's the second term? What's negative 1/3 squared?
Oh, there we go.
1/9. What's negative 1/3 cubed? There it is. And that's the rule. That's your nth rule for that one. It takes a little bit of time to sit there and try to figure out. You guys can figure out the pattern, but how do you write that out? It takes a little bit of getting used to. So your generic rule for this, that nth rule, would be negative 1/3 to the n. And that's how we would write that out. Okay? That's the generic rule. Some of them are really difficult. Some of them are easy. Let's try the other one. 2, 6, 12, 20. I'm going to write it in terms of a sub n. 2, 6, 12, 20. What's happening between each of the numbers?
Yeah.
Okay. 4, 6, 8. Okay. Now, remember, you're starting with your first term. So no matter what you do, your first term equals 2. I want to write the rule. How do I get the first term to equal 2? I'm going to have to take that n value, it has to equal 1, and I want to turn it into a 2. Okay, if I multiply it by 2. Then if I use my second term, I get 2 times 2, which would be 4. And that's not 6. All right. Rain teasers. It's like the thing that Josh gave us.
You hate that.
We do. No, we do.
For that, we do.
For that, we do, yes.
The rest of the time we
Just 2n.
How do you get the next one?
Add
1 times 6. Okay. What's another factor of 6?
Oh,
We're increasing what?
It was 3 times 2 and 6 times 2.
Then you multiply it by, so it's like 2 times 3, and then 3 times 4, and then 4 times 5.
Okay.
Oh.
Now write that out in terms of n.
It's fine, like that.
What do you got?
Something like n plus 2 plus n plus n 2 times 2. Why is it gotta be equal to anything? Is that the spot? What's the spot?
Right, if you
No,
start writing it down.
It's n times n plus 1.
Perfect. This is n times n plus 1. Take a look at what's happening. If your n value, your first term, would be 1 times 1 plus 1. The second term, 2 times 2 plus 1. And so on and so forth.
Oh, yeah.
It takes a minute or two to figure out how do you write it out in terms of the equation.
And that's what's gonna kill you guys, because you're gonna overthink. You go, ah, I know what it is. I know the next number, but how do you put that down? You're right. You picked up. Oh, they're just multiplying them through. There's other ways to do this. Someone earlier today said it's n squared plus n.
It's the same thing.
It's the same thing, yeah, but they thought, oh, right away there, oh, it's 1 squared plus 1, 2 squared plus 2, 3 squared plus 3, 4 squared plus 4. Works the same. I never thought of that, ever. No. But that's the same idea here. We're trying to figure out how do we write the pattern out. My suggestion, write down, if you're thinking it's 2n plus 1, write it down, try a couple, and then you'll see if you're right or wrong. Just mess around with the values, okay? You're gonna love it. It's fun. You don't hate it. It's just, it's not that. Well, okay. I almost said it and I didn't. I almost said it's just that. But I didn't. Let's take a look at what the difference here is between a sequence and then a series. What's the big difference between a sequence and a series? It should be glaringly obvious.
Addition, comma.
Yeah. A finite sequence is just a list of numbers. A finite series is you're adding up all of those numbers. That's the difference between the two. A finite series has the addition symbols in it. Same thing with the infinite series. You have addition symbols. You're trying to add them all up. You're trying to find the sum of a sequence. The sum of a sequence is called a series. And we write it out in sigma notation. So, the sum of the sequence is a series in summation. I can't even say it. The sum of a sequence is a series in summation notation.
That's a variation.
Yeah. You guys ever seen sigma notation before?
I'll recognize it right away if I have. Oh yes, I've
Oh, it is.
Sigma. It's a Greek letter, sigma. Means summation, add. Well, how many terms are in that series?
5.
5. The number of terms in the series goes up top. There's 5 of them. We're going to add 5 things together. Are we starting with the first term to add, or the third term, or the 6th term, or what? First term. You start with the first term. This tells me I'm starting with the first term, and I'm adding 5 terms together. What was the rule for that in terms of n?
Oh, it was
Was it
3n.
3 of them? Which basically means the following. This is equivalent to 3 times 1 plus 3 times 2 plus 3 times 3. That's what that means. You're adding those terms together. Yes, sir?
Isn't sigma in Einstein's theory of relativity?
No, that's E. That's
No, I knew it was an E. I just thought it was like a
No, that's a different E. That is the relativity variable. It's not a variable, it's constant. That's his thing. I don't know why he uses E. This is an E in his name. What's that? How did I get that?
Why is it in a
That's just that's how they write it out. Why is a fraction bar used for division? Because some Greek guy said so. It's basically all it is. They started using the summation symbol. It just means to add up those values from the first term through the fifth. So you're adding 5 terms together with this rule. 3 times 1 plus 3 times 2, and so on. So here we go. What's 3 times 1? Oops. What do these all add up to equal then?
3n.
45.
Would you believe it if I told you there's an easier way to do this?
I told her,
First and last.
Hit alpha, window, number 2.
Take a deep breath.
Alpha, window,
2. And you get summation notation on your calculator. You should never, ever, ever get a series problem wrong when you have to add things together. Because all you have to do here, it's asking you to put in all the spots. Now, our calculators don't have an n, but we have x. So just use x equals 1, because you're starting at the first term. You're going up through 5, and then you just put in your formula inside the parentheses of 3x, and hit enter. There's your answer.
45.
Again, your calculator will do summations for you. Okay? But sometimes the tough part of this is coming up with a rule. Okay? Did everybody get that okay on the calculator with the alpha? Okay. Now, what's the difference between a finite and an infinite series then?
How do you get it?
Well, you can't. Well, eventually we'll talk about some of an infinite geometric series. We will look at that later. But for right now, your calculator can't do an infinite series. So the only thing that changes for an infinite series is that the top number for something like this, still goes 1. What does it go through that up top? Infinity. And that's all you. Yeah. No, not necessarily. Like I said, we will look at how you can find the sum of an infinite series later on in this chapter. Okay? We might get to that Friday. Okay? Just so you guys know, we will do that. There's a formula for it.
So you don't get an answer?
You can.
You can.
Yes. We'll get to it. Don't worry. We will get to it. All right? One of the things I've been telling people throughout the day today with this chapter, there's quite a bit of formulas in it, and this is the chapter that I usually start letting people use the formula sheet that you will see that's on the final. That way you know what formulas you have to know and what ones you don't. It's not going to tell you when to use what, but the formulas themselves will be on paper. Okay, so you'll at least get the generics. So you'll see that when we start getting into the assessments of this stuff. Okay. Are we done? That. So what I want you to do here is write these two out in summation notation. Again, you have to come up with the rule prior to writing out in summation form. The summation notation is this sigma, the E. Okay. So you can figure those two out. Sometimes, what they do sometimes with things like this, instead of writing out, you guys all figured there'd be 20 terms here, they just put the dot, dot, dot in the middle of it. Here, when I cut it off, it'll just be dot, dot, dot at the end.
It is. I got that.
So what was your rule for A?
5n. 5n.
5n, good. So with the summation notation then, you went through 20, started at 1, it was 5n. What is that sum up to? Did you put that in the calculator yet? Figure out that? Over here, what did you get on B? What was your rule?
N plus 1.
Perfect. So your rule was n over n plus 1. And what do you go through on that one? Infinity. Good. Did everybody get over n plus 1?
Yeah.
Good. Now the fun stuff. What are you going to do?
Use Kelvin.
Use the calculator.
It's just the same thing, but a different variable.
Right. What number are they starting at in this case? 3. So when you type it in your calculator, it's not x equals 1, it equals x equals 3. All you do is just see exactly what you see on the page. You put it in your calculator and you hit enter.
Oh.
And that's all it is.
So
Now,
is case going up by 3, right? Or is it going up by 1 and starting?
in this case here, it's asking you to start at the third term, add the third through the sixth term of this series. So you would start at 3 and go to 6. So it would be 2 plus 3 squared plus 2 plus 4 squared.
Oh, so it's going up by ours.
Yeah, this is just the value to start at for k. K starts at 3, and you're increasing it by 1 each time to go up to 6.
So what's the
Yeah, because if it was,
go
if it
up
started
by
at 1, then a
like
different end result.
exponential, I guess, because it's
For the
3 plus 3, 6
Yeah.
plus 3, it's 9.
in summation notation, this value here, you're always going up by 1. What's the next term? This is the third term, fourth term, fifth term.
What you're thinking of, you're worried about what can happen inside here. That can happen later on, where we're actually going to use logarithms sometimes to solve for those different values. We'll get to that. Yes, sir.
I got 94.
I agree. That's what we got earlier. Yeah.
Does the 6 mean you go through 6 or
Yes.
you do 6?
You do go through 6. The 6 will be the 6th term in the sequence. In other words, you go to the calculator.
So you would just do one more?
Yeah.
You do plus 2 plus, and then that's it.
Yeah, and what was it, 94? Yeah, you just go through 6. And then the fun stuff. Way back in the day, you had to do this stuff by hand. 1 squared plus 2 squared plus 3 squared plus 4 squared, all the way up to 35 squared, and you had to crank that out by hand. Yeah, exactly. What is this? I wanted to say Russia, but I didn't want to offend you.
Thank you.
What is this? Australia?
Hey.
Crikey, mate. Put another shirt on the Barbie for you.
Forgot my.
What you used to have to do when this book was written, they didn't have these fancy finagled calculators all over the place. You had to memorize formulas. That's just silly. No reason to do formula work here, ladies and gentlemen, because we're not going to do formula work. Here we have buttons. Don't worry
Wait,
about it.
there's like formulas?
There's formulas to do this.
First, remember that high five? You have to add all
The loud one?
4,910.
Yeah. Yes, it would be a very bad day. So, there was a shortcut formula. We're not even going to bother with it. I'm not a point. You just use your calculator. Do these.
All of them are tomorrow?
Well, the thing is, you make like
All right. Really, really, really fast stuff. You will get frustrated on writing out some of the rules there. I do apologize. Try and get through as much of them as you can.
But what's up on